3s plus 6 divided by a square plus 4s plus 5, and I had solved also. Any doubt here?
No, sir.
Okay. Uh, so what else? Let us see. So there are some existence and uniqueness condition of Laplace transform. Means when Laplace transform of a function exists that we have not verified, uh, but there are some certain condition. If a function satisfies some certain conditions, then only its Laplace transform exists. So what are the conditions you may remember? I'm not discussing about that. Existence and uniqueness condition. Okay, of Laplace transform. So it is the first condition. Laplace transform of ft exists if modulus of ft less or equals to m into e to the power kt. Okay, it is one condition which is called growth restriction. It is one condition, and another condition is that the function should be piecewise continuous. Now, do you know what is meant by piecewise continuous? Do you know or not? So, see, I am giving you a small example. A to B, it is an interval. Okay. Now, if I draw this type of graph, then it is continuous in AB interval, right? Because there are no break.
Yes, sir.
But if I draw this type of graph, then is it continuous?
No, sir.
No, because there are several points of discontinuity. But you can see, we can divide that interval into some sub interval uh, where the function is continuous. Like I'm telling, uh, look, I have splitted the interval AB in that way, A1. So in the interval A1 the function is continuous. In the interval A2 A3 the function is continuous. In the interval A4 B it is also continuous, right?
Yes, sir.
So what we can see that however the function is not continuous throughout the interval AB, but we can see that in some sub-interval of AB, it is continuous. So if this happens for a function, then it is called piecewise continuous. मतलब इसको पीस पीस करके कंटिन्यूअस सोच सकते हैं, मतलब एक एक पीस कंटिन्यूअस है ऐसे कुछ मतलब फाइनाइट नंबर ऑफ पीसेस है जो कंटिन्यूअस है. ओके, so this type of continuity it is called piecewise continuity. So that is also one kind of example of piecewise continuous in the interval a comma b. Okay, so these are the main points in existence and uniqueness of Laplace transform. What are the condition? Again, I am repeating. You just remember it linguistically, nothing else. No need to think about the means no need to think about it much more because you don't know what is meant by this. So it is actually one kind of boundedness. Okay, so you remember, matlab, the Laplace transform of ft exists if ft is piecewise continuous in the interval ab and the function satisfies this growth restriction. These two conditions. You see, it is written as theorem 3. If ft is defined and piecewise continuous on every finite interval on the semi-axis t greater equals to 0 and satisfies 2. Satisfies 2 means that growth restriction. Then Laplace transform exists. Now let us come to a problem set. So we will solve some problems from this exercise. Uh, oh, I am not showing for problem number 1. It is a simple one, right? Laplace transform of 3t plus 12. What it will be? Can you tell me? Laplace transform of 3t plus 12. What it will be? It is, I can write 3 into Laplace transform of t plus 12 into Laplace transform of 1. Can I write this?
Yes.
Yes, sir.
Yes, sir.
So it is equals to what? Laplace transform of 3 means 1 by a square and Laplace transform of 1 means 1 by s. So it is 3 by square plus 12 by s. So Laplace transform of a constant. It is what? Laplace transform of say 96. It is 96 by s. Now what you will do in that case, Laplace transform of a minus bt whole square. AB constant. There is no direct formula, so you can think uh, you can think about linearity property of that Laplace transform. Okay. So what you have to do? First of all, you expand the whole square formula, expand it by whole square formula, right? A square plus b square t square plus sorry minus 2abt. Then you take Laplace transform. Then there will have three terms: Laplace transform of something plus Laplace transform of something plus Laplace transform of something. Will you be able to do that, or do I need to solve? Bolo.
Sir, can you solve?
I have solved various problems already. You have to. Otherwise, मतलब बहुत difficult हो जाएगा. ये simple सा problem अगर solve नहीं कर पाओगे, then it will be difficult to solve the other types, harder types. The Laplace transform of a minus bt whole square. Laplace transform of a square uh, plus b square t square minus 2abt. So a square constant. I can write a square Laplace transform of 1 plus b square Laplace transform of t square minus 2ab Laplace transform of t. Right? अभी देखो. Now you can do it.
Yes.
Laplace
Yes,
transform
sir.
of 1, it is what?
A square by s.
1 by s.
1 by s, ultimately a square by s. Then
The 2b square by s.
So b square by
S cube by s cube.
s cube. Yes,
Minus 2ab by s square
2ab
by s square.
divided by s square. This one. Now that is simply cos pi t. So like cos omega t in the table it is given like cos omega t, and here omega is pi. So directly you can tell me what is Laplace transform of cos pi t. Can anyone?
s
S
by s
upon s
square
square plus
plus
pi square.
pi square.
Repeat.
S by s square plus pi square.
Yes, s by a square plus pi square. And what about cos square omega t? I don't have any tabulated formula for cos square omega t. So any idea? Bolo? Can we write cos square as cos or sine? What is the formula for 2 cos square theta? 1 plus cos 2 theta, right?
Yes.
Yes, sir.
So means cos square theta, that is 1 plus cos 2 theta by 2. Theta is what? Omega t. So I can write 1 by 2, that is the constant term. 1 by 2 Laplace transform of 1 plus 1 by 2 Laplace transform of cos 2 omega t. Right? Any doubt?
No, sir.
Now just you put the formula 1 by 2 s plus 1 by 2 into what is the Laplace transform of cos 2 omega t? If you know cos omega t, then what is the problem with cos 2
S
omega?
by s square plus 4 omega square.
Uh-huh.
S by s square plus 4 omega square.
Yes, it is s divided by a square plus 4 omega square. Means it is our omega now, 2 omega. So s by a square plus omega square, and omega square it is 2 omega, or 2 omega whole square. That means 4 omega square. Okay. Next, e to the power 2t sine hyperbolic t, or e to the power minus t sine hyperbolic 4t. These are for these two problem you can apply case shifting theorem, or it can be solved directly without applying. Uh, if you want to solve it directly, then you write the formula for sine hyperbolic t here. Okay, what is the formula for sine hyperbolic t? E to the power t minus e to the power minus t divided by 2. then you multiply it by e to the power 2t. So after simplifying, it will be of the form e to the power 3t minus e to the power t divided by 2, right? You do it. I That is why I am doing some rough work. You can do e to the power. Therefore, what e to the power 2t into sine hyperbolic t, that is basically e to the power 3t minus e to the power t divided by 2. Now Laplace transform. You take Laplace transform over it. It is possible. No, you know Laplace transform of e to the power 3t. You know Laplace transform of e to the power t. Similarly, for the problem number 6, you
Sir,
huh,
sir, the answer will be 1 by 2 into 1 by s minus 3 minus 1 by 2 into 1 by s minus 1.
yes, correct. So
Okay, sir.
similarly, you can do this, na. First of all, you put the formula for sine hyperbolic 4t. So what is the formula for sine hyperbolic 4t? Can you tell me? It is e to the power 4t minus e to the power minus 4t divided by 2. That is sine hyperbolic t. It's for sine hyperbolic t, it is e to the power t minus e to the power minus t by 2. In general, actually, sine hyperbolic at, it is e to the power at minus e to the power minus at divided by 2. Then it is multiplied with e to the power minus t. So you multiply it with e to the power minus t, then simplify and take Laplace transform. Okay, complete these two problems. Now problem number 7. See, problem number 7, it is sine omega t plus theta. So Laplace transform of sine omega t plus theta. Now if it is only sine omega t, Laplace transform of sine omega t, then it is simple. We can find the Laplace transform. But it is omega t plus theta. So what we will do? Look, one thing you can do, to write it in the form of sine omega t or cos omega t, you can expand it in the form of sine a plus b. It is sine something plus something, na? So sine a plus b, you think. Then you apply the formula for sine a plus b. What is the formula for sine a plus b? Bolo?
Sin A cos B plus cos A sin B.
It is plus or minus. You check it. I forgot actually. Uh, the terms I remember sine a cos b cos a sin b, but it may be plus, maybe minus. You check it
It's
once.
plus, sir.
This. Okay. Now here the variable is t and theta is constant. So overall cos theta constant, sin theta constant. Whenever we took Laplace transform of what? A function of t. So here the variable is t, theta is constant, omega is also constant. Therefore cos theta constant, sin theta constant. Now what I can write? Can I write cos theta into Laplace transform? मतलब ये cos theta बाहर आ जाएगा ना Laplace transform से, क्योंकि ये constant है. Sin omega t plus sin theta L of cos omega t. Do you get it?
Yes, sir.
बोलो समझ में आया कि नहीं, कुछ डाउट है यहाँ पे, कैसे हुआ? Simply these are constant, so constant can be taken outside to the Laplace transform by the linearity property. So I have written this line by the linearity property. Now, now we know Laplace transform of sine omega t. It is what? Omega divided by a square plus omega square. Don't write mistakenly a square minus omega square. Okay, a square minus omega square, it is for sine hyperbolic, and it is s by a square plus omega square. So you can take 1 by a square plus omega square common, then it will be omega cos theta plus s into sine theta. So what do you feel? Means that Laplace transform, it is interesting, more interesting than power series solution, or
यस
same?
सर, सारा चैप्टर उससे तो इंटरेस्टिंग है।
Hmm? क्या सारा
पावर
चैप्टर?
सीरीज तो सर, पावर सीरीज सर तो सबसे बेकार था सर।
बेकार नहीं है, वो कब काम आ जाए बोल नहीं सकते। थोड़ा कैलकुलेटिव, थोड़ा नहीं मतलब कैलकुलेटिव है, बहुत सारा वो कैलकुलेशंस करना पड़ता है वहाँ, एंड बहुत बड़ा बड़ा है, ये दिक्कत है। Now see, problem number 8, it is also similar type, right? Like problem number 7, it is omega t plus theta, and here it is also omega t plus theta form. In place of omega it is 3, and in place of theta it is minus pi by 2. So again you expand it in the form of sine a minus b, it is something minus something. So sine a minus b formula, apply it. Then you take Laplace transform, you will get it. So it is also easier, similar to problem number 7. Now see, there are some problems related to graphs. 9, 10, 11, 12, 13, 14. These are related to graphs. So how to solve it? For this question also, what is being asked, that find the transform, means you have to find the Laplace transform. So here instead of function they have given you the graph. So from the graph first you construct the function, then you take its Laplace transform. Okay, that is the way. Now can you tell me what is the equation of this graph in the problem number 9? It is clearly seen that the graph is passing through 1 0 and 0 1, means in the, what is the form, line, means segment form, or what is the form of straight line, I forgot. X by a plus y by b is equal to 1. What is the name of this form? Intercept form. Yes, intercept form. So here the both of the intercepts are 1. So it is x by a plus y by a, matlab x by 1 plus y by 1 is equal to 1. That will be the equation of this straight line. Are you getting, or you are thinking I'm talking about some theory? Do you remember intercept form?
Yes, sir.
It is both of the intercept, x-axis intercept and y-axis intercept, both intercepts are 1. So equation of the straight line will be x by 1 plus y by 1 is equal to 1. Right? So simply x plus y is equal to 1. Now one problem is there with these two variables. The problem is that we don't know, means whenever we took Laplace transform, we usually take Laplace transform of a function of t, right? But here it is not exactly function of t. It is in the form of say, x and y. We can convert it to x means t and ft. Like in that case, what you will do? You consider x as t and y as ft. Okay, so that is the graph against t and ft. Therefore, the graph will be what in terms of ft. So it is y is equal to 1 minus x. Therefore, I can write ft is equal to 1 minus t. Right? In the interval,
Yes.
in which interval it is lying over the real line or all over the real line, or in a some part. It is a line segment, no? So it is not lying in the uh, all over the real line. So what is the range for t here for that function? 0 to 1, right? Only that this is the portion, no, in the t axis, 0 to 1. That is the domain. So here the graph of the portion, it is lying in the interval 0 to 1, not all over the axis, t axis. So ultimately our function is what? F t is equal to 1 minus t, 1 minus t in the interval 0 to 1 and 0 elsewhere. Okay, मतलब ऐसे लिख सकते हैं as a piecewise function. Do you get it?
Yes, sir.
That is the equation of this graph of this straight line. Now no need to show this part. You can do the rough work for this. Now Laplace transform of ft, what is it? So I cannot write Laplace transform of 1 minus t. Why I can write? Because it is the function is not lying all over the means positive real axis. Positive means t greater than 0. It is lying in some sub part of it. अगर ये मतलब मैं क्या बोल रहा हूँ कि अगर ये स्ट्रेट लाइन पूरा पॉजिटिव रियल एक्सिस के अलोंग अगर lie karta, then we can apply Laplace transform of 1 minus t, but it is not lying all over the positive t axis. So for that, what I will do, I have to use the definition. For this type of function, whenever the function is defined in a small interval, in that case, we will use the definition. So what is the definition of Laplace transform? this. Now I can split that integration into sum of two integration, like 0 to 1 and 1 to infinity, because the function is piecewise function. Accordingly, I have to break this integration, right? So 0 to 1 e to the power minus st into ft dt plus 1 to infinity e to the power minus st ft dt. Do you get it? Why I have done this? Because the function is piecewise function. In the 0 to 1 interval, it is one kind, and otherwise it is another kind. Piecewise function. So एनी डाउट बोलो, यहाँ पे कैसे क्यों किया या कैसे किया, कुछ डाउट है? I am using the basic definition, actually definition of Laplace transform. I cannot use the direct formula, tabulated formula. Reply.
Yes, sir.
Now what? In the interval 0 to 1, ft, our ft is what? 1 minus t. So you put it. Here you put ft is equal to 1 minus t, and second part will be 0, na? 1 in the interval 1 to infinity, the function is 0. So second part is 0. No tension for the second part. करो, complete करो इसको. Put ft in the first integration and then you solve that integration. Okay, now you simplify it. Do you get it or not? यहाँ पे just what I did that I have applied eyelet rule for that second integration 0 to 1 t to the power minus s t dt. Okay.
Yes.
So second in the last line you put the limits in the second and third term. I'm struggling with the space actually. Minus 1 by s a to the power minus s minus 1, and if we put 1, then it will be a to the power minus s, and for 0 it is 0, so it is only to the power minus s, not 5. Okay, don't think this that is 5, it is s. And for the last, you write it clearly. Actually I'm writing in small place, a to the power minus s. No, one term will be there now. This, क्या मैं बोल दूं यहाँ पे क्या लिखा हुआ है और समझ गए?
Yes, sir.
Just to solve this integration and ultimately you simplify it.
सर
हाँ,
सर वो जो स्टार्टिंग में एफ टी इज इक्वल टू 1 - t उसके नीचे से 0 क्यों लिखे हैं सर?
look, there are no part of this graph na outside that interval 0 to 1. 0
यस सर.
to 0 to interval के बाहर में ग्राफ का कुछ पोर्शन नहीं है. That is why I have written 0. You can ignore that 0 also.
ओके सर, ओके सर.
एक्चुअली यहाँ पे ये सेकेंड पार्ट लिखना सही नहीं है. कब ये सेकेंड पार्ट लिखना सही है वो मैं बताता हूँ यहाँ पे ग्राफ दिखा के. ठीक है, जैसे यहाँ पे देखो प्रॉब्लम नंबर 9, ओनली ब्लू कलर्ड लाइन इज lying in the interval 0 to 1. Okay, there are no other place where that blue color line is there, right? In the problem number 9, but 11 में क्या है देखो, 0 to b में ब्लू कलर का डॉट है, ब्लू कलर का लाइन है, एंड b to infinity में वो एक्स एक्सिस के ऊपर भी ब्लू कलर का लाइन है. तो ये लाइन का इक्वेशन क्या होता है? 0, मतलब y इज इक्वल टू 0, राइट? मतलब b के बाद जो लाइन का इक्वेशन होगा दैट इज y इज इक्वल टू 0. मतलब ये केस में फंक्शन का जो इक्वेशन आएगा वो मतलब एफ टी इज इक्वल टू समथिंग, एक केस आएगा इन द इंटरवल 0 टू b, एंड ये नॉट 0, दैट इज समथिंग. ओके, एंड 0 अदरवाइज, क्योंकि 0 ग्राफ यहाँ पे दिख रहा है, एफ टी इज इक्वल टू 0 वाला ग्राफ दिख रहा है, राइट? बट दे हैव मेंशन्ड बी के बाद एक्चुअली वो 0 होता, ये यहाँ पे ऐसे एक लाइन मेंशन होता ब्लू कलर का. आर यू गेटिंग व्हाट आई मीन टू से?
यस सर.
तो वो ये पार्ट रहने से या नहीं रहने से कोई दिक्कत नहीं है, सेम टू सेम होगा. मतलब ये 0 के लिए क्या होगा, लैप्लास ट्रांसफॉर्म 0 के लिए वो पार्ट रहेगा ही नहीं एक्चुअली. Now what is the okay, you just after that last line you simplify once and ultimately write the similar terms together like you can take e to the power minus a minus a's common from some of the terms. Okay, so you can write that. No, so that is the end of this Jamboard link. You can download it as a PDF. Now, okay, I will not do any other problem today. The next class I will show one or two more graphs and their Laplace transform. So I'm discussing about problem number 10. What is the equation? Can you tell me what is the equation of ft? It is simple one. Look, this portion it is parallel to y-axis. So for that, what is the equation? Sorry, my mistake. Parallel to x-axis, right?
Yes, sir.
Then what is the equation of that line? Y is equal
Y
to
is equal to K.
Y is also
k. Y is equal to constant. Constant means the height of this line, and it is k, right? So y is equal to k will be the line equation. So ft is equal to k in the interval, which interval? 0 to c. And other case में, if it is greater than c, then it is 0 for t greater than c. Okay. So for that function, you find the Laplace transform of it. तो ये करके मुझे नेक्स्ट क्लास में बताना कि इसका Laplace transform क्या होगा. What will be the Laplace transform of ft? You apply the definition 0 to infinity e to the power minus st ft dt. तो हियर ऑल्सो यहाँ पे इंटीग्रेशन को ब्रेक करना पड़ेगा दो इंटीग्रेशन में 0 टू c एंड c टू इंफिनिटी. तो c टू इंफिनिटी में इंटीग्रेशन 0 हो जाएगा एंड 0 टू c में एफ टी के पुट करेंगे एंड उसके बाद इंटीग्रेशन करेंगे. सिंपल है. आई एम टेकिंग अटेंडेंस नाउ. तुम ट्राई कर सकते हो.
Okay, sir.
प्रॉब्लम नंबर 10. सेवन 42,
Present, sir.
44, 45.
Present, sir. 44 present.
Okay. 46,
present, sir.
47,
Present, sir.
48, 49.
Present, sir. Sir, 48 present.
Okay.
Written in the chat.